Okay, so solving equations, fairly straightforward. An equation statement where two expressions are equal, if it has an equal sign, it's an equation. Okay. Solution of an equation, the answer. Inverse operations undo each other. Identity and equation that is true for every variable. Little equations have at least two different variables in it. Rearranging a formula is, the area of a trapezoid is a literal equation. Several variables in it. Okay. Inverse operations. The key to solving an equation and the key to doing almost anything in math is using the opposite to undo something. If you're adding if you have an addition on one side, you want to get rid of the addition, x plus 5, you subtract. Do the opposite. The most important thing you have to remember is if it's equal, it's in balance. As long as you do the same thing to both sides of the equation, you maintain that balance. We're going to do some pretty odd things, some pretty complicated things later on this year to solve equations. And as long as you do them both to both sides, you're okay. There are a few times where you have to keep special circumstances, have to keep certain things in mind, but you can do that. My calculus kids are going to do some very, very intense things to equations, but as long as they do it to both sides, they're okay. So you got to maintain that balance. That's equal. You got to keep them equal. You maintain that, each side of the equal sign gets the same thing, then you're going to be okay. Questions? Okay, basic properties. Okay. If two things are equal, then you can add the same thing to both sides and they will still be equal. Makes sense. If two things are equal, then you can subtract the same thing from both sides and they will still be equal. If two things are equal, you can multiply them both and they'll still be equal if you multiply by the same thing. And if two things are equal, you can divide both sides by the same thing, and this needs to be fixed. This is A divided by C equals B divided by C as long as C is not equal to 0. You cannot divide by 0. Marlene. Okay, yeah, you cannot divide by 0. Yes. Yeah, the multiplication is the same way too. Thank you very much for catching that. A times C equals B times C. I'll try to remember to correct that later. Thank you. Don't always catch mistakes. Thank you. Yeah, you can basically do anything you want as long as you do it to both sides. One of the things about math that I really like, and one of the things that makes math unique and very strong in academics is it's got a rigid set of rules. There's not a lot of fuzziness in math. It works or it doesn't work. It follows the rules. We follow the rules. It works. If it doesn't, we don't do it. If it doesn't have a rule to tell us how to do it, we don't do it. Okay? Now, they're discovering new rules and proving new rules. That's what mathematical proofs are about, are proving that, hey, if we have this condition, then this condition is true. And we skip all the crap in the middle, we can go straight from here to here. That's what mathematical proofs are about. Okay? The only fuzziness are ideas that have yet to be proven or disproven. If something's disproven, we never use it. It gets tossed out. That's what makes math strong. Okay? There's not fuzziness. It is or it isn't. Makes it nice for me for grading purposes. It is or it isn't. Okay? Not a lot of gray areas, but it makes it really strong. Academically, there's nothing as strong as mathematics. Anything else, you can have things that, well, it's kind of a little off or kind of a little off, and it's okay as long as it follows the general plan. But with math, no, it's all or nothing. Okay? Questions? Okay. So example number 1, determine if the following are always, sometimes, or never true. So you have an expression. Okay. And you want to know, is it always true, sometimes true, never true, before even continuing? Sometimes you can get to a point where you say, listen, I know there's no solution. Why bother going on? Okay. So the first thing you do, combine up any like terms on each side. Okay. And you do that, you get 3x plus 6 equals 15x minus 8. And I already know if it's always, sometimes, or never. I already know. Without doing anything else, I already know if it's always, sometimes, or never, without any more steps. Okay. If the variable portion of each side of an equation is different, then it is sometimes true. I have 3x on one side, 15x on the other side. They're not the same. There is one solution. That one solution is where it is sometimes true. I can solve this and get x equals, well, in this case, let's see, 14 over 12, 7/6. X equals 7/6. That's the sometimes that it's true. When x is that number, it's true. If it's anything else, it's not true. That's the sometimes. If the two variables are different, I don't have to go any farther. I know I have a solution. Now, what if they aren't different? If it's the same and the constants are the same. So if the variable's the same and the constants are the same, then it's always true. If I get one thing on one side of the equal sign exactly the same as the thing on the other side of the equal sign, then it's always true. X can be anything. If I get 3x plus 5 equals 3x plus 5, well, 3x plus 5 always equals 3x plus 5, irregardless of what x is. That's always true. Okay? And if your variables drop out, so you get 4 equals 4, the variable portion is the same. It doesn't exist. And I have two sides equal. That means anything will work. Okay? So the variables are the same and the constants are the same. Anything works. So that means that if we have the variables the same and the constants are different, nothing works. 2x plus 3 will never equal 2x minus 5. There is nothing that will work for that. And if the variables drop out and all you have are two numbers, which often happens, variables disappear, you've got two numbers, and they're not the same, you end up with 4 equals 10. 4 doesn't equal 10, nothing works. There is no solution. There's no solution. That's what that means. No, can't do it. Okay. So the idea is we simplify the equation without actually solving it all the way, and we can tell what kind of answers we have without actually solving the problem. You don't always have to go all the way to the end. You don't always have to go to x equals something to figure out what you need to know. Because if I have these two here, these two situations here, I don't need to go any farther. I'm done. Why should I do extra work? You know, that's kind of what this is about. Everything works, nothing works, or we have one thing. If we have one thing, we solve it. But if we have these two situations, you just get to where you know it's everything or nothing, and then you stop, because that's what you have. Everything works or nothing works. Okay. Do those three. You do not need to solve them, but you do need to figure out if it's always true, sometimes true, or never true. Okay, so let's take a look at these. And once again, my apologies for not working these problems out. I will work out some later. Like I said, I'm just trying to not screw up my shoulder so I can't move my arm at the end of the day. Okay. So first step, like I said, combine up like terms. 4a plus 5 equals 4a plus 5. Hey, It's exactly the same on both sides. It's always true. Always. A can be anything. If I take 4 times some number and add 5, that's exactly the same as taking 4 times that same number and adding 5. Same thing on both sides. So again, first step, simplify it down. And on this one here, 3n plus 4 equals 3n plus 5. Variables are the same, the constant are not. It's never true. The variables are the same and the constants are not. It will never work. Nothing will work at all. Okay. This one required a little bit more work. Your first step is actually to distribute and then combine up like terms. And then I get here 5y minus 6 equals 3y minus 12. They are completely different variables. So this is sometimes true. You would be able to solve it out. And you would actually get y equals -3. But you don't have to do that, but you could. Okay? Questions? Like I said, sometimes it's nice to know, hey, I'm done. Everything will work. I'm done. I don't need to go any farther. That's kind of nice. Okay? So, this is an example. Justify each step. Every time you solve a mathematical equation, every time you solved an algebraic equation, you were doing a mathematical proof. Just like you did mathematical proofs in geometry, you're doing them with an algebra. Every time. So, the difference between what you did in algebra, all you did was one side of the proof. You did a 2-column proof, but you only did one of the 2 columns. Geometry 2-column proof, you have your steps and then you have your reasons why. Okay? Same idea here. Now, the first one is given. I don't write that one down on these. Basically, you go through and what can I use? My first step to get to the first thing, the second thing, is I use the distributive property. What did I do? I distributed. Okay? Distributed the 3, distributed the -2. I use the distributive property. To get from here to here, I combine up my like terms, which technically is using the addition property. Technically, it's the addition property. Then I have -11 equals 11y. What am I doing to both sides? Dividing both sides by 11. That is the division property of equality, because I did it to both sides. That's why it's the division property of equality. And then I actually did my division to get my final answer. It's not as neat as it is with the geometric proofs. And I know you guys hate proofs. All kids hate proofs. I love it, but I'm a math geek, so it's me. But this is more to demonstrate it's the same thing. Mathematics is a rigid set of rules. To get from the first to the end, to get from the top to the bottom, I can only do the steps that I have rules that let me do those steps. If I don't have rules that let me do those steps, it doesn't work. Okay? You have to have the rules or you can't do it. Everything you've done, mathematically, there is a rule that lets you do it. At some point, it's not worth going over each and every rule that lets you do it. But this is an example of, hey, you've been doing this all along. Okay? There are certain things like dividing. Why is dividing a fraction, dividing by a fraction, the same as multiplying by its inverse? I can explain it to you, and I will explain it to you later on this year, but it's awfully hard to explain why you do it until you get a certain level of mathematics. 6th graders and 5th graders, they don't understand that. But when we get to this class, later on, I'll be able to explain it to you and go, oh, that's why you do that. Because it makes sense. You have the background. Okay? Same thing here. Okay. Now we get to our literal equation part. solve the little equation for the indicated variable. So I need to take this equation, s equals 3f minus 24, solve for f. My steps and processes are exactly the same, irregardless of what the equation is made up of. If it was f and a bunch of numbers, process is the same. So if I want to get f by itself, my first step is to add 24 to both sides. That's exactly what I would do if I didn't have s there, but I had a number. I would still add 24 to both sides, right? Difference is s and 24 cannot be combined to one thing. It is s plus 24 equals 3f. I can't put s and 24 into one thing like 3 and plus 24 would be 27. I don't know what s is. I can't combine it together, but I can have it as an expression. I still want to get f by itself. What do? Divide by 3. And I get f equals s plus 24 over 3. And that's the answer. Okay. My steps are the same. I want to get a variable by itself. I get rid of everything else that's with it. I add, subtract, multiply, divide. Same thing on this one. I want to get b by itself. Now, when I do this one, I like to do it in more than one step. I could technically do it in one step. I don't like doing this problem in one step. First thing I want to do is get rid of the 1/2. What do I multiply times 1/2 to make it into 1? 2. So I multiply both sides. Because remember, I have to do both sides. Multiply both sides by 2. The 2 and the 1/2 cancel each other, and I have 2a equals bh. Okay. bh is b times h. Opposite of multiplying is dividing. I want to get rid of the h. So I divide both sides by h. And I get 2a over h equals b. That's the answer. Piece of cake. Yes, ma'am. Because what is BH? BH is B times H. Okay, so if I want to get rid of, what's the opposite of multiplication? Division. Yeah, you want, yeah, because it says solve for B, so you want to get B by itself. Any other questions? It's early. Give her a break. Any other questions? Okay, do those two. Essentially the same process. Okay, so first one, solve for B. Subtract 13 from both sides. And I get A minus 13 equals 9B. When I get B by itself, divide both sides by 9. And A minus 13 over 9 equals B. B, there's a little bit better on the B. Questions? And on this one, same idea as that. Get H by itself. Once again, if I have several things in there, if I have a fraction, I want to get rid of the fraction first. I like to do that no matter what. Get rid of fractions first. Whenever you have fractions, get rid of them, multiply by the common denominator. Everything by the common denominator. In this case, that's 3. So multiply by 3. Those cancel. 3a equals RH. And I want to get H by itself, so I divide both sides by R. 3a over R equals H. So you understand when we divided by R, right? Questions? Any questions? So I believe, yep, that's it.